Okay, we're looking at continuing section 10.8. Up to this point, we looked at simplifying negative numbers under a radical, under a square root. And now we're going to look, and we looked also at adding and subtracting numbers in complex form. So now we're going to go ahead and take a look at what's involved in multiplying radicals. So this gets a little tricky because the order in which this is done is very important. So let's go ahead and we'll start taking a look first at question 36. So in question 36, we have the quantity of 6i times 9i. So we're multiplying these now. So what we're going to do is we'll go ahead and multiply 6 times 9, and that's going to equal 54. Nothing real complicated about that. Then we're going to take the quantity of I times I, and that's going to give us I squared. So remember what we covered in the beginning of the first video, where we talked about the idea that I squared is equal to negative 1. So one way we can rewrite this answer is we can rewrite this as 54, okay, times negative 1, because I squared is equal to negative 1. So we'll replace I squared with negative 1, and that's going to give me the value of negative 54. So when we multiply 6 times 9, that's going to give us 54. But when we multiply I times I, that gives us I squared. I squared is equal to negative 1. So I multiply that through to 54 to get negative 54. So these are just the little tricks that we're going to encounter in doing questions like this. Let's take a look now at question 37. So in 37, we've got the quantity of negative 4i times the quantity of negative 6i. So what we're going to do in this question, to kind of clear up the confusion, because we're going to have a lot of negatives flying around here, is let's just take negative 4 times negative 6. We know that negative 4 times negative 6, so one thing that you may find easier to do is just taking negative 4 times negative 6 times I times I. So we just kind of do this in this order, which is okay, because if everything's being multiplied, we can reshuffle this around. Negative 4 times negative 6, well, 4 times 6 is 24, and a negative times a negative, that's positive. So we're going to leave that as positive 24. I times I is going to equal I squared. And again, as we mentioned before, we know that I squared is equal to negative 1, so I can write this as 24 times negative 1, or I can write this as negative 24. So again, we have to deal with the idea that I squared is equal to negative 1. Let's see as we carry this through a little further and see how we treat such problems once radicals get involved. Let's take a look at question 40, and here we have negative radical 49 times radical negative 25. So what we're going to do in this problem is we're not going to multiply radical 49 times radical 20 times radical negative 49 times radical negative 25 first. We're going to simplify each of these radicals. So what students will try to do sometimes is say, oh, well, I know if I multiply 49 times 25, the two negatives will multiply to a positive. Cannot do it this way. We need to simplify underneath each radical first. So here's one of those properties of working with square roots, where it's not quite as flexible as we've learned about earlier, not at least in the complex number system. Here we need to simplify the square root of negative 49, or let's see, if the square root of 49 is 7, then the square root of negative 49 is going to be 7i. If the square root of 25 is 5, that means that the square root of negative 25 is going to be 5i. So this looks pretty similar to the couple of problems we just did. We have 7 times 5 is going to be equal to 35. I times I is going to be equal to I squared. The square, or I squared, is equal to negative 1, and that's going to be equal to negative 35. Now, if you were to just go from 35i squared straight to negative 35, I have no particular objection to that. But as I'm teaching this, I figure I would, try to walk you through this as much as I can. Okay, let's go ahead and take a look at a problem like 44. So what we've got in 44 is the following problem here. So we have the square root of negative 15 times the square root of negative 10. So one thing that we're going to do in this problem is I'm going to go ahead and write this as radical 15i, because I can't simplify that, and then I'm going to take this and write this as radical 10i. Again, noting the i's are not underneath the radical. If I want to, I can do a couple things. I can take radical 15 times radical 10 now, and I can multiply it to get radical 150. I can then take radical or I times I, and then get I squared. So now that I have the square root of 150, okay, I can take the square root of 150, and I could simplify this as much as I can. I can write the square root of 150 as 25 times 6. I know the square root of 25 is going to be 5. So I write this as 5 radical 6. I also happen to know that I squared is equal to negative 1. So if I take this and multiply by negative 1, I know that's simply going to be negative 5 radical 6. And that's going to be my final answer. So all of this up here is going to simplify to negative 5 radical 6. So let's take a look at, so that's basic principle how we multiply a couple of these together. Let's take a look now when we have to distribute a monomial through a binomial. It's going to be 46 here. So this is going to be 2i times 7 plus 3i. So let's see what this distribution is going to look like here. Kind of just an extension of the work we were just doing. Not terribly difficult, but can be a little troubling for a student sometimes. So if we take 2i times 7, we can multiply a real number times an imaginary number. And it's just going to be 2 times 7 will be 14, and the I comes along. So this is going to be 14i. That's the first part here. When I take 2 times 3, that's going to be 6. I times I will be I squared. And what we find here is we're now going to have this written as 14i. Now, this 6i squared, this is going to be negative 1. It's going to switch the sign of this, so it's going to make this negative 6. If you're asked to put this answer in complex form, that means that you're going to need to switch this around. You're going to need to write this as negative 6 plus 14i. Remembering that we have to write this in a plus bi form. In this case, where a is equal to negative 6 and b is equal to positive 14. Notice we don't include the I here because it is a plus bi form, not a plus b form where the b includes an I. The I is kept separate from b. We just acknowledge that there's a number in front of I, and the number is 14. So the math here is not difficult, but it's just tricky and takes some time to get familiar and comfortable with all of the notation. Well, let's continue on and do some more questions in multiplication here. So let's go ahead and take a look at 48. This is going to be negative 4i times the quantity of 6 minus 5i. So from here, I'm going to take negative 4 times 6 will be negative 24. I times nothing will be just I. Negative 4 times negative 5, well, 4 times 5 is 20. Negative times negative is positive, so it's going to be positive 20. And then I times I is going to be I squared. So what I like to do, instead of just keep writing this as negative 1, I just want to switch the sign of this positive 20 and make it negative 20. So now I'm going to write this as negative 24i minus 20. Because where do we get the negative from? The I squared that's equal to negative 1. Now as I do this, remember, they're likely going to ask you for the answer in a plus bi form, which means I need to make this as negative 20 minus 24i. And that answer is finally written in a plus bi form. So let's go ahead and take a look at how we multiply a binomial times a binomial. And this math is going to seem all too familiar with you. It's just a question of getting comfortable with multiplying I terms together and dealing with the I square as that result. So if we have a question like 50, where it's going to be 4 plus I times 2 plus 3i. Well, how do we handle something like this? You can FOIL if you're comfortable with that, but I'm going to be using a Granny's box here to kind of put this together and consolidate my terms. So here I'm going to write 4 plus I, and then 2 plus 3I. So this is going to give me 2 times 4. That'll be 8. 2 times I will be 2I. 4 times 3I will be 12I. Then 3I plus I is going to give me 3I squared, or it's just going to give me negative 3. So, not to cross out your work entirely, but know that that is not the final number you're going to work with, because you need to make the I squared into negative 1, and then multiply by 3 to get negative 3. So I'm going to take the information here, and what we're going to find is that when we're multiplying numbers like this specifically, is we're going to be able to combine a few things. 8 minus 3, that's going to result in 5. I do that first because I'm going to write this in a plus bi form. Then 12i plus 2i is going to be 14i. So all this now is going to equal 5 plus 14i. And now my answer is written in a plus bi form. Let's do a couple more before we get to, well, not a couple more, maybe 3 or 4 more, before we take a look at more complex problems involving imaginary numbers. Let's begin to take a look at 54. So this is going to be the quantity of negative 4 plus 5i times 3 minus 4i. So notice all these numbers, these binomials, are written in complex form. So again, I'm going to put my my Granny's box together here to perform the calculation. So this is going to be negative 4 plus 5i. This is going to be 3 minus 4i. So it's going to be 3 minus 4 will be negative 12. 3 plus 5i is plus 15i. Don't have to put the plus on. I just choose to put it. Negative 4 times negative 4i is plus 16i. Then negative 4 times positive, negative 4i times positive 5i. Negative 4 times positive 5 is negative 20. I times I is I squared. So negative 20i squared actually becomes a positive 20. So here's an instance where we're seeing an I squared actually makes something positive because the resulting coefficient next to it's negative. So we have 20 here for our final answer in this box once we simplify the term with the I squared. So we have negative 12 here plus 20, so that's going to be 8. And then 16i plus 15i is going to be plus 31i. So we have 8 plus 31i as the final result of that question. One more problem before we begin to look at this at the next level. You may see another problem written in this way. Let's go ahead and take a look at 64, as I think it's probably a more extreme example of what this is going to look like. We may have negative 5 minus 2i, and that quantity is squared. So remember, if you have something like this that's squared, it's everything that we've learned before. You're just only working with the I term, so we're giving you a lot of examples to make sure that you're comfortable with that. So this is going to be negative 5 minus 2i times negative 5 minus 2i. And we're going to do a Granny's box for this again to perform the calculations. So this is going to be here, negative 5 minus 2i, negative 5 minus 2i. So negative 5 times negative 5, that's going to be positive 25. Negative 5 times negative 2, that'll be 10i. Negative 5 times negative 2i is going to be plus 10i. And then negative 2i times negative 2i, that's going to give me 4i squared, or is going to just consolidate down to negative 4. So again, I want to make sure to put everything in complex form. So this is going to be 25 minus 4, or 21. And then 10i plus 10i is going to give me plus 20i, giving me the number in complex form of 21 plus 20i. Third video coming up will show how to simplify rational expressions where there's an I in the denominator using the conjugate that we've used before. and how we can simplify a value of I raised to any whole number exponent.